All right, so back to completing the square. So far we've used complete the square to solve or to factorize, but we're actually going to see, I think, its best application today. So remember how we do it. So if we've got this trinomial here, we need to note that it's in ax squared plus bx plus c. And what we want to do is actually write it in this form here, because hopefully you've gathered that in the last two lessons, if I have a parabola that's written like this, x take 3 all squared plus 4, I know that the turning point of this parabola will be 3 comma 4, okay? Because 3 to the right and 4 up will take the turning point, which is usually at the origin. It's going to shift it 3 units to the right and 4 units up. Okay, so this is actually called turning point form. Okay, and so if we get our parabola that look like this into this form here, we can actually read off the turning point. Right, so how do we do it? Well, again, it's the same process that we've explored earlier. It's completing the square. So what we do is we fence off those first two terms there. Okay, so put some brackets around it, and then we'll note that this thing here is an incomplete square. So what we do is we complete the square by adding something, okay, and that will be half of this and that amount squared. Now when we do that, what that will do is make a perfect square. So I can simply take that sign there, and the base that would make this square number here. Okay, so that's going to be 2, and that's for that reason I write that as 2 squared. And then take 4 plus 7 is plus 3. Okay, so note that this trinomial here, okay, which is y equals x squared take 4x plus 7, has a turning point of 2 comma 3. Okay, so that and that trinomial, that and that are all the same thing, okay, except in this form here, we call it turning point form. So the parabola here will turn at 2, 3. So it says in the notes here, you'll be able to read off the coordinates of the turning point 2, 3, obtain the y-intercept. That's quite easy to do. Remember, you just slam in, or the y-intercept occurs when x is equal to 0. So slam in 0. Negative 2 squared is 4. 4 plus 3 is 7. So that occurs at 0, 7. And we don't need to proceed any further with the solve. And in this case, we actually can't. You can't solve this because it doesn't have any x-intercepts anyway. So it's no point trying to get the x-intercepts if they don't exist. So let's do a couple of examples for each of the following. Start by completing the square to find the turning point and sketch the graph, labeling all key features with coordinates. Right, so what's the turning point going to be? So let's do it. We're going to fence that off. Okay, and we're going to say that this is x squared plus 6x. Halve it and square it and add it. So we're going to add 9 or 3 squared plus 10. Okay, remember what that will do is make an incomplete square a perfect square by the thing that we added. And that was silly of me because I added it, I forgot to subtract 9 and then plus 10. All right, so that will make that a perfect square. So that's going to be x plus 3 all squared. That subtract 9 plus 10 is going to be plus 1. Okay, so what's the turning point going to be? It's going to take the standard turning point of 0, 0, and it's going to move 3 units to the left and 1 unit up. Okay, so negative 3, 1 is our turning point. So we can sketch that now and really see what this thing might look like. All right, so here is negative 3 and here is 1. So we put our turning point there. Now let's grab the y-intercept. There's two ways of getting the y-intercept. Is you can put 0 into the function in turning point form. Let's try it. 0 goes in. That's 3. 3 squared is 9. 9 plus 1 is 10. Or you can actually just do it in the original function. Just slam 0 in there quickly. And you'll note that with a trinomial, that it's always the constant that is the y-intercept as well. So there's 1. We're going to pop 10 up there, just making sure that our scale is roughly right. Okay, and let's swing our parabola over through that y-intercept and make it symmetrical over the other side. Now that parabola is a little bit V-like there, so I'm not really happy with that. I'm going to try and smooth that out. Okay, that's not too bad. Okay, and this is the axis of symmetry here, x is equal to -3. So it should be roughly symmetrical about that axis of symmetry. All right, so let's label our key features, 0, 10 for the y-intercept and -3, 1 for the x-intercept. Starting now. All right, so we've got the trinomial here, x squared take 2x take 8, and we're going to use two methods this time to grab the turning point. So let's do it with the method I just taught you, which is completing the square. So we're going to say that this is y equals x squared take 2x, and we're going to halve it and square it and add it. And then we're going to remove it. We're going to grab that perfect square that I've just made. Okay, so we can see that our turning point is going to go 1 to the right and 9 down. So it's going to be 1, -9. Right, so let's pop that in to a graph. Okay, so there's 1. Let's go -9 there. Okay, and let's grab the y-intercept. Occurs when x is equal to 0. Now I could slam it into this one here. 0, -1, -1 squared is 1, 1 take 9 is -8. Or I could slam it into this form of the trinomial, which is actually a lot easier when it's in expanded form, because what it will be is just the constant out here at -8. So -9, -8, -7. Yeah, around about there. Let's go there. Right, so there and symmetrical. Here comes our parabola. Let's pop the key features in. 1, -9, 0, -8. All right, so there's our parabola at that stage. But let's see if we can think of another way to do this. Okay, so with the trinomial, I'm going to rewrite it again. And just to show you that there's just so many different ways of doing things with quadratics, you're just going to be really flexible with them. So what I'm going to do is try to factorize that. Now, why? Okay, just go with me on this. X, and that's going to be negative. X take 4, x plus 2, 0 equals x take 4. I'm trying to find out the x-intercepts here. X equals 4, x equals -2. Okay, I'm going to draw this Cartesian plane now. And let's mark in our x-intercepts. So 2, 4, -2, 4. Now, what do I know? They're the x-intercepts. The y-intercept is at -8 still. What about the turning point? Well, if I didn't know how to complete the square, is there enough information here or on the graph itself to get the turning point? And the fact of the matter is, there is enough information. So what I know is the axis of symmetry, the midpoint of this parabola, will be actually at the midpoint of these two x-intercepts. And if you remember back to the start of the year, I can get the midpoint from linear by going -2 plus 4 over 2. I average the x values. That's going to be 2 over 2, which is 1, which seems to make sense because here's 1 here. I'm just going to draw a line, 1 along there. That seems to make sense that it's the midpoint because it's a distance of 3 to get to -2 and 3 to get to 4. It also makes sense because what was the axis of symmetry on this parabola here? It was along the line x is equal to 1. Right, once I know what the axis of symmetry is, which is x is equal to 1, I can slam this value into my original equation, which is, let's do it, y equals 1 squared, which is 1, take 2, take 8. That's -1 take 8, that's -9. So when x is equal to 1, the y value is -9. And we just need to note that the turning point is always going to be on the axis of symmetry, okay, because it has to. You can't have a turning point here turning outside the axis of symmetry. It's got to always turn on the axis of symmetry. That's going to be 1, -9, and I could quite easily sketch my parabola using x-intercepts as well. So do you have to do it like that? No. but it's just some added flexibility to what you can do. You don't have to complete the square to do this process. Okay, so let's just try a couple more. So I'm going to sketch this one by grabbing the turning point. So this is going to be y equals x squared plus 3x, halve it, square it, add it. That's going to be 3 on 2 squared, take 9 on 4 plus 1, which I'm going to write as 4 over 4. Y equals x plus 3 on 2 all squared, take away, what is that, 5 on 4. Turning point, 3 on 2, negative 5 on 4. Okay, so that says it goes 3 on 2 to the left, 5 on 4 down. Okay, so let's sketch, rule this up properly. So I'm going to pop negative 3 on 2 here, negative 5 on 4 there. That's going to be my parabola. Okay, and my y-intercept occurs when x is equal to 0. I can get it off the original function here. So here's negative 5 on 4, which is negative 1.25. So we're going to have a y-intercept of 1. So there's negative 1. So 1 is going to be up here somewhere. 1. So it's going to go through there, and via symmetry, it's going to go through there. Let's sketch it and see how we go. Ooh, that's terrible. Okay, so symmetrically, it should be moved over a little bit like that. Okay, so I'm just going to bring that point in a little bit there. Okay, now again, just note a couple of things. No wobbly parabolas, please, girls. If yours comes out like that, please erase it. Just draw it with a nice smooth curve. Okay, let's label our key features, which is y-intercept there, and turning point is negative 3 on 2, comma, negative 5 on 4. Okay, noting that we're not required to do the x-intercepts just at this stage. All right, let's try this one. Okay, so mark this one in. This is a real problem, this question, for students in Year 11 methods, even Year 12 methods. The girls still struggle with these ones here. So what we're going to do is try to sketch this one, and to first grab the turning point, we'll complete the square. So the rule is with the completing the square process is you don't want to do it when there's a negative coefficient here. You want a coefficient of 1. So the first move we're going to make is factor out the negative 1 and rewrite this as x squared plus 5x take 2. Right, now we're ready to complete the square on the internals there. So we're going to say that this is negative x squared plus 5x plus 5 on 2 all squared. So halve it, square it, add it. Now we need to subtract it, 25 on 4, and we're going to remove 8 on 4 or 2. Right, so y equals negative x plus 5 on 2 all squared, take, what's that? Negative 33 on 4. Okay, so here's the mistake that students make. So students will say that the turning point of this function here is negative 5 on 2, so it goes 5 on 2 to the left, and 33 on 4 down. Okay, and so that's roughly negative 2.5, and negative 33 on 4 is negative 8.25 or negative 8.25. All right, so if we graph this thing, all right, what should happen is we should get a turning point, negative 8 and negative 2.5. So the turning point is going to be somewhere here. So let's find out by graphing the original function, which is negative x squared, take 5x plus 2. Just check it out and see. So turning point down here somewhere, okay, according to this. Ooh, that's awkward. Turning point is up here. And it looks like it's gone positive. at 8.25. This says it should be negative 8.25. What's happened? Well, invariably, the issue is that the student will forget that this negative sign here applies to both this thing here and this thing here, i.e. we've got to distribute this out. So this is negative x plus 5 on 2 all squared, and then negative times a negative is going to be positive, which is 33 on 4. So now we actually can write the turning point. The turning point is negative 5 on 2 as stated, and 33 on 4. All right, so let's put together our graph. Get rid of that so I've got some room. Okay, I probably shouldn't have kept this video running and subjected you to that, but never mind. Okay, so here's our turning point at negative 5 on 2 and 33 on 4. So there it is there. Now that negative means, remember that it's an inverted parabola, so it's going to go like this. The y-intercept is at 2. So 33 on 4 is 8, 6, 4, 2. So 2 is there. Right, so it's going to go through there. It's going to go through there. Okay, let's see how we go. Oh, that's the best parabola yet. Okay, that is a very nice looking parabola, that. Okay, so turning point negative 5 on 2, 33 on 4, and our y-intercept when x is 0, y is 2, remembering that we're not worried about the x-intercepts yet. All right, so the questions that I need you to do now are from 7D. They're those questions there. Please do not include the x-intercepts. Okay, we're not worried about those just at the moment.